So for these problems, we are really just doing the same thing as we did before. We're going to use this golden rule that whatever you do to one side of the equation, we have to do the same to the other. Okay? The real big rule is we need to keep it balanced. So these ones just are a little bit more involved and they have variables on both sides. But what we want to do is make sure we get all the variable parts on one side, all the numbers on the other side. So what I'm going to do here is I'm going to undo the plus 4 with the minus 4 on both sides. I'm going to undo the plus 2a with the minus 2a. So I can subtract variables and create 0 pairs. Just have to make sure I keep my balance. Okay, so this is what I want to see. I want to see opposites, okay, and I want to see balance. So these are my 0 pairs. Those disappear. So I'm going to end up with 3a equals 20. Okay, and then when I divide that, I'm going to divide by 3, divide by 3 on both sides. So same thing again, I need to see the opposite operation, so divide, and we end up with a equals 20 over 3. Okay, you can change that to an improper fraction, or sorry, a mixed number if you like. Okay, that's 6 2/3. Okay, but I prefer you leave it as an improper fraction. So here again, the idea is we want to keep it balanced. That's the only rule we have. We just need to keep it balanced. So I need to, but I want to solve for a, so I'm going to get rid of this a by using an opposite. So I'm going to get all the a's to the left-hand side. So I want to get rid of that plus 7 with a minus 7. Again, showing my balance, okay, showing my opposites. My 0 pairs, I'm just going to make sure I get rid of all those 0 pairs. 13 minus 7 is 6. Okay, again, divide by 2, and I get my a is equal to 3. Okay, so again, the important part of this is showing steps. Okay, the final answer is not worth very much. You need to be able to show me steps. Okay, so here I'm going to maybe move the a to the, get rid of that a, so minus a, so I'm going to end up with an extra minus a on the left-hand side, so that's negative 7a. Okay, once we start having a negatives, you have to be careful with our integer addition subtraction, so we're going to combine those together. On the right-hand side, I have positive 21. When I divide by negative 7, I'm going to get rid of the times by negative 7. I have to remember to divide this side by negative. Positive divided by negative is negative. Okay, for this one here, we can combine our like terms first maybe. So I'm going to end up with negative x plus 7. It's always a good idea to combine like terms when you have a chance. So 2 minus 1 is going to be 1. Okay, please don't do things like this. Oh, minus and positive, they cancel each other like that. Okay, that's not true, right? The only thing that you can get rid of on both sides is when they're exactly the same. So here I like to deal with the positive x's, so I'm gonna get rid of this negative x, and it ends up as a positive x on this side. So there's my 0 pair. That means I want to get rid of the minus 3. Sorry, get rid of the plus 3 with the minus 3. Okay, again, my 0 pairs there. And so I end up with 4 is equal to 2x. So it doesn't really matter which side the variable is on. In fact, if you really want, you can just switch it around, because when I divide by 2, it's balanced, and I can just switch the balance around and say that x is equal to positive 2. Okay, now we don't have to do that. It's perfectly fine to leave it as 2 equals x. So again, we want to make sure that we can draw pictures for these. It's very important that you're able to draw pictures because you'll be asked to do this for part of your evaluation. So we want to draw the initial picture. You don't have to use a picture to solve, although we can, and we have those apps that allow us to kind of move things around to make sure that we're balancing things. So here my initial picture is going to look like this. I'm going to have 3 x's on this side. Okay, so there's my algebra tiles for x's. I'm going to have 5 1's. I'm going to have 1x on this side and 1 1. Okay, so we could solve this. We can just say, we can take off x and x. We can do something like, we can do this, take off an x here, take off an x here, take off 1 here, take off 1 here. And it looks like 2 x's and 4 1's equals 0, so those x's must be -2. Okay, so we could solve it like that if we want. However, I also want to see the algebraic solution. Okay, so what I can do here is I can do a minus x. That's taking away those 2 x's. Okay, in fact, I'm going to start compressing some of my steps. As we get better at this, we can start doing more things in one step. So I'm going to take away the 5 from this side, and 5 from this side. I'm just going to do that all in one step. 0 pair, 0 pair. So 2x equals -4. Divide by 2, divide by 2. And sure enough, I get my solution that x must be -2. So here we want to draw our algebra tile model. So 2 x's. And I'm not really too concerned if you make the positives shaded or in the negatives white or the other way around. As long as you're consistent, okay, as long as you're not mixing things up, that's perfectly fine. So we can get rid of this negative with 1 positive. And if you remember how to use algebra tiles, you can make a 0 pair like this with a positive. That means you need to balance with a positive here. Okay, we can make that disappears. We can make 0 pairs here as long as we balance those here. Then we get these canceling out as a 0 pair, and we have 3 x's equals 3 1's, so each x equals 1. So you don't need to solve using the balance, you just need to be able to draw the balance. You need to be able to show me the steps when we actually solve this algebraically. So I'm going to add an x to both sides to make a 0 pair there. I'm going to add 2 to both sides to make a 0 pair here, and that's what we did up here. That's exact same steps, so we end up with 3x equals 3 1's. Okay, so then divide by 3, divide by 3, we end up with x equals 1. Okay, and which is what our balance shows us as well.